Welcome to NASA Science Live, an opportunity for you to interact with NASA experts and have your questions answered in real time. I'm your host, Tahira Allen. We are so happy to have you here today to dive into the mysterious world of planets in retrograde. If you have questions throughout the show, you can send them in using the hashtag AskNASA on social media, or you can drop your question directly into the comment stream wherever you're watching. Now, some of us may groan when we hear about certain planets being in retrograde. But what on earth actually is retrograde? Well, it is a fascinating phenomenon in our solar system that involves planets and how they appear to be moving in the night sky. We have two very special guests today that are here to answer all of your burning questions. Dr. Henry Throop is a program scientist at NASA headquarters. Welcome, Henry.
Hello, glad to be here.
Thank you so much. And we have Dr. Marina Broskovich, who is a planetary scientist at NASA's Jet Propulsion Laboratory.
Pleasure to be here, Tahira.
Now, thank you both so much for joining us to talk about, what it means to have for a planet to be in retrograde. And Henry, if you could just kick us off with that exact question. What does it actually mean for a planet to be in retrograde?
So retrograde means backwards. And there's a couple of different places that we use that in the solar system where we talk about things being in retrograde. If you look at the solar system, all the planets and everything, they're pretty much going the same direction. In fact, if you were to zoom out above the solar system, look down upon it, like this animation, and all the planets are orbiting in the same direction. And they're orbiting in the same direction around the sun, and they're also mostly rotating in the same direction. And if there's something which is moving in the opposite direction, you can call it retrograde. Now, there's not very many things that actually orbit backwards, because if you're orbiting backwards from everything else, it's kind of like driving down the highway and in the wrong direction. If you're going this way and everything else is going this way, you're going to have a collision and it's going to be game over. So there's not too many of those things which are orbiting in the retrograde direction. But there's a couple of planets that are actually spinning backwards, and so rather than spinning in this counterclockwise direction, as seen from above, they're spinning in the opposite direction. And Venus and Uranus are the two of those that are spinning backwards. And so that's what we mean about something spinning in retrograde. And finally, then, there's the most common usage of retrograde. And that's where things actually look like they're moving backward, but they're not. It's kind of an illusion. And what's going on there, it's actually, again, kind of like the highway. If you're driving in the fast lane, and there's this slow truck over you next to you, and you want to overtake it, you pull up to that truck, and you look out your window, and that truck looks like it's moving backwards as you overtake it. And that's kind of what we're doing in the solar system. The Earth is sort of the fast lane because we're close to the sun, and we're overtaking these slower planets like Mars and Jupiter, which are further out, further from the sun, so they're moving slower. And so as we look out our window, essentially, we see Jupiter and Mars and the other planets outward, and they look like they're moving backward in that period where we're approaching them and passing them. And so that's when we say that those planets are moving retrograde.
So in our solar system, it's kind of just an optical illusion with that explanation, you would say.
Yeah, the planets are still moving forwards. The orbits are in, just like in the animation, the orbits are still going seen from above. They're going counterclockwise, and those orbits are stable, and they've been doing that for billions of years. But as we overtake these slower moving planets, they look, from our perspective, like they're moving backwards in the sky.
So, Marina, can you explain to us then why aren't any planets in our solar system in a true retrograde orbit?
Well, that has to do with how our solar system was forming from a rotating protoplanetary disk, and it has to do with the subsequent orbital evolution of the newly formed planets. So basically, the planets today, they're orbiting in the same direction as that original cloud of dust and gas from which they formed. So there are physical mechanisms that can flip the orbits so that planets start going the other way. But if such conditions ever occurred, those planets were not long-lived, because we obviously don't see any planets in our solar system that are going backwards today.
Interesting. So an orbit can tell you a lot about the formation of a solar system.
Yes, orbits, each orbit tells a story.
Wow, I love that. And Henry, how can retrogrades affect us Earthlings?
So, it used to, I mean, people have been looking up at the sky for thousands of years, right? And so it used to be, in every culture across Earth, people have had names and stories and about the stars and the planets and the constellations. And those stories really connected people to the sky and the world around them. And people used to think that the planets controlled us, like where the stars were when you were born actually influenced you. And that's because back thousands of years ago, we didn't know much about physics and biology and human behavior and those sorts of things, which actually do control our lives. And so now that we understand much better how the solar system moves, the laws of physics and biology and so forth, we're in a new era where we understand this stuff much better. But you know what? It's kind of interesting. The more we know about physics, the more people actually, I think, like to go outside and they like
Yeah,
to see the planets and the
explore.
moons, the comets, and meteor showers, and all these other things in the sky. We like to observe those for themselves. And you don't need a telescope or binoculars. You can see the motion of the planets just with your eyes. You just look up, and from one night to the next, to the next, to the next, you can see the motion of the planets and you can see them move. And people love having this connection with the solar system today, much like they did thousands of years ago, even though our understanding of the physics is so different now.
And Marina, can you actually
Mm.
talk to this evolution of humanity's relationship with the planets over time?
Well, humankind has been we've been fascinating, but these bright specks of light moving against stellar background since the beginning of time, and we so even the word planet in Old Greek, it means wanderer, so the wandering star. In the antiquity, we only knew about 5 planets. We did not know about Uranus or Neptune. And we thought about planets in highly abstract terms. They were part of the heavens, with Earth at the center of the universe. And as Henry mentioned, they were even thought to be representation of gods. Now we know that planets are not they're not revolving around Earth, they're revolving around the sun. We even developed a branch of science called celestial mechanics that describes their orbits. And I would say that today we are probably even more fascinated with planets because we can study them from close up. We have these powerful telescopes and space missions. And so that really these little bright specks of light become worlds to us, and they write that we become even more curious about them.
Thank you both so much for this fantastic introduction to planets and planets being in retrograde. Now, we have lots of questions coming in online right now from our viewers. And if you're just tuning in with us, remember you can submit questions for our experts to answer live on air by using the hashtag AskNASA on social media or by dropping them directly into the comments wherever you're watching. But first, a question for our viewers before we start. What is your favorite planet to be in retrograde? Think about it. Drop your answer into the chat wherever you're watching. Now, let's take a minute and get to some of these Ask NASA's. Our first question is from Kevin Warrens on Instagram, who asks, do all planets in our system, I guess, go into retrograde? So, Henry, why don't you take this one?
Yeah, so um, you can answer that in a couple of different ways, so all the planets, orbit in what we call the prograde, the normal direction, and that isn't going to change even over the course of billions of years from when the planets were formed. But from an observational standpoint, from when we overtake that planet or pass that planet, that happens with all of the other planets, and that's going to happen for the planets which are, both further away than we are, like Mars and Jupiter and Uranus and Neptune. And for planets inward of us, like Mercury and Venus, you're going to see the motions of those planets sometimes move forward and sometimes move backwards in the sky. Now that's kind of like this perspective thing, kind of like passing cars in the highway. You're all moving in the same direction, but based on
Yeah.
your perspective, they're going to look like they're moving forwards or backwards.
Oh,
Yeah,
cool.
i
Thank
can
you.
i can add to that.
Yeah.
Yeah,
Marina.
I can add to that. For example, so Mercury, has this, it's orbiting very close to the sun. It has orbital period around the sun of 88 days. So it kind of overtakes Earth several times a year. So Mercury is actually apparently retrograde in the sky several times a year. But if you look at Jupiter, Jupiter is only, once a year, and it has to do with Earth overtaking its orbit. So it really depends. It can happen for inner planets. Now for Mercury, it happens fairly often. For the outer planets, it happens about once a year, but it lasts much longer. They apparently move in the sky backwards for months, as opposed to Mercury that only spends a couple of weeks moving backwards. This is all. When I say moving backwards, it has to do with respect to stars. So.
Okay. Yeah, and on this topic of Jupiter, so we have Ali Daghi on YouTube who asks, is there a mission to learn about Jupiter's moons? Henry, Marina?
Jupiter is probably one of the best studied planets that we have in the solar system. It's of huge interest to NASA and to people around the world. We've sent a large number of missions up to Jupiter. We have one up there right now, which is called Juno, and we have another one on its way, which is a collaboration with NASA, or with ESA, the European Space Agency, called JUICE. Juno is focusing mostly on the planet itself, not focusing on the moons, but it's doing some fantastic flybys of some of the moons, including Io, coming up shortly. Io is a moon which has volcanoes on its surface and one of the most dynamic and active places in the solar system.
Thank you.
And
Henry.
I also
Marina?
had to.
Yeah,
I
please.
would just like to add that I forgot to mention Europa Clipper. The Europa Clipper is NASA mission that is going to be exploring the moon Europa, and I actually have the privilege of looking at the spacecraft right now. They are building it in the clean room just behind my building. So that is one of the privileges working at JPL, that I can take a peek of how they're doing, and this ginormous spacecraft is growing in the building next door, and it's going to be launched next year.
Thank you both. And so, Marina, I have actually a great question for you. It's definitely not Faith on Instagram. Oh, sorry, I read that wrong. Fantastic129 on YouTube says that I am 14 years old and have a question and want to know, does the sun spin? And if so, which way?
Absolutely. So sun is spinning, and actually really fast, very rapidly. It is spinning in a prograde direction. So because, as I mentioned, it really has to do with the way the whole solar system formed. So from this rotating disk of gas and dust, and so everything spins the same way. Sun spins the same way, and orbits and the planets are revolving around the sun in the same way. And sun is obviously a star, and its layers of sun tend to spin in the they know to have actually different speeds with which they spin. But on top of my head, sun is, I think its period is spinning is something in hours. But maybe Henry can correct me if I'm wrong here. But it is spinning pretty rapidly.
I think the solar rotation period is on the order of a month or so.
Solar rotation period, the sun, really? Okay.
So 24 days is what it is.
I remain corrected.
And
but
we can also,
because it's so big, the diameter of the sun is so huge. So in kilometers per second that it's moving, it's probably moving faster than anything else in the solar system, just because of its size, coupled with its rotation.
I was remembering Jupiter. Jupiter is a very rapid.
Jupiter.
Yeah, Jupiter is very.
Jupiter goes around in about 10 hours. It's super fast. Yeah.
Yeah, it's order of hours. Yes.
So our next question is from definitely not Faith on Instagram. Henry, this is a good one for you. Do other planets go through seasons just like Earth? And I'll tack on a second part to that. How do their orbits affect that as well?
Yeah, so we go through things like seasons on all the planets. The seasons on Earth are influenced by where the North Pole is and what the tilt of the Earth is relative to the tilt of other things in the solar system, such as the orbit of the Earth or the orbit of the other planets. And so all of the planets go through different seasons to different amounts. Uranus is one which goes through seasons essentially more than anything else because it's tilted essentially on its side. And so you have half of Uranus that for you know dozens of years is seeing the sun full on, and then on the other half of its orbit, the other half of it's seeing the sun full on. And so um, its seasons are sort of the most extreme of anything else in the solar system.
Well, for many reasons, lucky us, we do not live there. And so we have our next question, who is Rekha on Facebook, who asks, should we associate retrograde as a bad omen or that bad things will happen? Marina, Henry, either of you feel strongly about that one?
Yeah, it has really nothing to do with us. It's just the optical illusion, as Henry mentioned in the intro. It looks neat on our night sky to see a planet moving opposite direction. That's what we expect. But it really, in the grand scheme of things, it's just a pretty sight. It has really no influence on us on Earth.
And I want to go back to Uranus. Henry, I think now everybody is really focused on that planet, that topic. We have Asani Yurda on YouTube who asks, why does Uranus show the retrograde motion and what are the reasons behind its axis 97-degree tilt? Basically, like, why do we know why it is that way?
Yeah, so Uranus is mysterious here because we unlike the other planets, it's really tilted on its side there. We think that it might be due to an impact in its past that tilted it. We think that it probably formed in the same way as the other planets, spinning in the same direction. But then a couple of possibilities that it could have been impacted by something else, like another small planet, large planet, something like that, and tilted around, or a gravitational interaction with something else. And I think Marina knows a little bit more about your star.
Yeah, well, it really is. I mean, Henry kind of pretty much summarized it all. But so basically, if Uranus was just your regular planet, it would just be spinning in the same direction as it's revolving around the sun. But instead, it's kind of tilted 98 degrees on the side, and it's more kind of rolling like a little barrel around the sun. And this is really this big question of why it is that way. And what is also fascinating, not only is the planet tilted on a side, it's the entire system of rings and moons is also tilted on a side, which is kind of tricky to explain with just the impact theory, because the impact would be just tilting the planet, but now we are talking about the system of moons also being tilted on a side. Uranus is a future destination for NASA missions. So hopefully next decade or something. And I really can't wait for us to have a kind of grand spacecraft mission like Cassini was around Saturn.
Fingers crossed. And so, on this topic of planetary orbits, what can they tell us about solar system formations? Marina?
So yeah, as I was mentioning before, you really kind of have to look at each one of them individually. For example, so we established there are no retrograde planets because everything, the initial protoplanetary disk from which the entire solar system formed was spinning in the same direction. So, for example, I like to mention my favorite topic and objects that fascinate me are the retrograde moons of the outer planets. For example, maybe I would like to start with the planet Saturn. Saturn has, it has this great system of rings, and then it also has a system of regular moons. And it has 24 regular moons, and these regular moons, what you see, they orbit in nearly perfect circles. in equatorial plane of the planet and in the same direction as the planet is spinning and revolving around the sun. But then when you pull away from the planet, you are entering the realm of so-called irregular satellites. And the reason why they are called irregular is because their orbits are really all over the place. They are orbiting planet at great distances. So the ones that are shown here in yellow, those are still orbiting in a prograde direction. But the larger population, these red ones, they are orbiting in the opposite direction. And I always say, orbits tell a story. Basically, what this tells you is they were not original to the system. They didn't form with the planet itself like the regular boots. They didn't form from the same circumplanetary nebula. These guys were captured by Saturn, and sometimes in the early history of the solar system. And we still don't fully understand the physics behind this capture, and we really don't know their source region. But there are currently, we know 122 of these guys, and there's more to come. And what is really neat is that all outer planets, so Jupiter, Saturn, Uranus, and Neptune, they all have population of these irregular captured satellites.
And I have a great follow-up to that. James, PCY on YouTube asks, what is the use of these retrograde observations? So, you mentioned that we observe them, they tell a story. Henry, could you share any specifics about what we're trying to learn from observing these irregular orbits?
What we learn by observing is that everything is a clue in kind of doing the forensic analysis of how did the solar system come to be. And so you look at the orbits of the big planets, you look at what they're made of, you look at the orbits of the small stuff, much of which is kind of left around from when the solar system formed. And you put that all together, and piece by piece, it's kind of like looking at the puzzle. Piece by piece, you can assemble the picture of how the solar system formed. And that's kind of what we're going after, is trying to understand the formation and evolution of the solar system, formation and evolution of Earth, and formation and evolution of life on Earth. Where did we come from?
It all gets back to those origins. And so on the topic of observations too, we have James White on YouTube who wants to know, how do we know that a planet, say for example Uranus, is rotating on its side? Marina?
Well, this comes really from observational data, and we have big telescopes that can resolve planet really, really well, and it's just the feature tracking. So, first of all, we see that entire system is tilted. So we're kind of looking at it like almost bullseye. So instead of looking at the system of rings, kind of you're seeing them parallel to your line of sight, you're seeing Uranus tilted on the side. So you're kind of looking really kind of bullseye system. And we know which way planet is rotating but you're looking where these clouds in the atmosphere are, and so we that's pretty well established. And we actually have Voyager 2 flew by both Uranus and Neptune, and those are our best data on that system, and hopefully we are going to see it again soon.
So when you say observational data, is it like these spacecraft are taking videos and you can actually see it spinning on its side?
Yes, correct.
Okay.
Hubble can resolve it really well. James Webb, I saw some fantastic images from James Webb. Close up, just a quick picture of the system. And I'm really interested in these inner satellites of Uranus. There are 13 of them. They're orbiting really close to the planet, and they're interleaved with the dust rings. And they're not easy to see because they are faint, and they get lost in the bright glare of the planet. And James Webb, with just like even a very short exposure, you can see them clearly, all of them popping out, and it's a really fascinating system.
Thank you, Marina. Now, our next question is from Mama3 on YouTube, who asks, does NASA have any plans to study Venus? Now, Henry, I know this was a favorite planet of yours. Why don't you take this one?
Yeah. So, Venus is a planet which has been of interest and it's been studied in the past, and is of huge amount of interest to NASA right now. In fact, we have a mission in the pipeline called Da Vinci, which is a deep atmosphere mission. It's going to which goes down to the surface of Venus through its atmosphere. Let me just tell you briefly about Venus here, because it's um, all the planets are unique. But Venus has something really different with it when we talk about its spin, because um, Venus it's roughly the size of Earth. It's roughly made of the same stuff of rocks of the Earth, but it has this super thick atmosphere, like you're kind of peering through in this video here. And this atmosphere is like 90 times thicker than Earth's atmosphere. And so it really controls the system in a way that it doesn't control in a much bigger way than it does on Earth. And so we actually think that what's happening with Venus's rotation is Venus is essentially not rotating, or it's rotating backwards at a very slow rate. It takes more than a year to rotate, more than one of its years to rotate. And we think the reason why is because the atmosphere is actually influencing and kind of dragging down and interacting with the surface to pull Venus around in a different way than it would happen in a planet with a much smaller atmosphere. And so that interaction between the surface and the atmosphere and the dynamics of how the atmosphere works is one of the things which is going to be studied by the Da Vinci mission, and then by a number of other missions in the pipeline down the road.
Thank you, Henry. And so I'm going to go back to a question that we already hit on earlier in the show, but for our viewers that are just now tuning in, definitely not Faith on Instagram asks, do other planets go through seasons just like Earth? So, Marina, you want to take that one?
So everything that has any tilt goes through seasons. For example, Saturn. So Earth is tilted 23 degrees, and that's why we have seasons. So, instead of Earth is not spinning perfectly perpendicular to its orbit plane, it's actually tilted 23 degrees. For example, Saturn. Saturn is tilted 27 degrees. And something very dramatic is going to happen to Saturn rings because exactly of this tilt. In 2025, we are going to be seeing them like edge on. And for a little bit, because they're very thin, we are going to actually not see, kind of almost not see them for a little bit. So that is actually one thing that always, fascinated me about Saturn rings. They're incredibly, they're huge. It's like 300,000 kilometers wide. But thickness is less than a kilometer, and actually most of it is only a few hundred meters. So it is actually incredible that you can see it from this huge distance from Earth. You are seeing something that is so delicate, and I'm saying, and we get to see different views of the Saturn rings because Saturn is also going through seasons.
Wow. And I mean, that is really exciting. So, while we give our viewers some more time to drop in some questions, I want to focus on this idea of orbits with planets being in retrograde. And earlier, again, we've been touching on these weird, wacky, unconventional orbits, and I do want to ask a fun question. Marina, I know that you're all about the irregulars, the satellites, things like that. Are there any satellites or comets, asteroids, things like that that you find most fascinating with maybe again an unconventional orbit?
Yeah, we know that there are a lot of comets that actually have retrograde orbits. We also have a population of asteroids, relatively small one, that are also in these retrograde orbits. So obviously they are some physical mechanisms. So either it was gravitational interaction with the planets, or some kind of other mechanism that ended up flipping them, and so they are actually revolving the sun the opposite way. And people were actually inspired to even have claims about captured interstellar objects, because it knows to be that stars are forming in clusters. The material around one star doesn't necessarily go in the same way as the material of another star. And if they're forming close together, sometimes one star ends up stealing material from another star, maybe another object. And that's how you end up with this, kind of object going the other way than anything else. Now, these are usually not very long-lived, and actually, the conventional wisdom these days is that really we don't have evidence for any of the asteroids really being interstellar, that there are these other more plausible physical mechanisms to flip their orbits. But who knows, in the Oort cloud from where the comets are coming from, there were these papers that were showing that maybe in the Oort cloud, the material there, so some of the objects there that are in retrograde orbits are truly originating from different star systems from the same little cluster where our sun was forming.
Wow, and I mean it's pretty crazy to think that this is all still a mystery. Like every observation just puts together one more piece of the puzzle. And I want to take a moment right now and remind our viewers that you can submit a question for our experts to answer live on air by using the hashtag AskNASA or by dropping your question directly into the comment stream wherever you're watching. Now, while we give our viewers a second to drop those questions, I have a question for both of you. What do you find most fascinating in this field? Henry, we'll start with you and then Marina.
One of the things that I think is fascinating here is that the laws of physics can, describe so well and so easily the motions of the solar system. And many people watching, I'm sure, have taken like a high school physics class, and you learn, very early in that physics class, the Newtonian laws of mechanics. You have F equals ma, and the law of gravity, which involves the g and mm over r squared, which is the masses and the distances. And so you have the forces and the gravity, and you balance those things, and that pretty much explains the motions of the bulk of the motions of the solar system. And you can write those equations down on a postage stamp, and that explains the large scale motions of the solar system and the universe. Now, there's a lot of other things that come in that change those to various degrees, but by and large, just the basic physics, which we've had for hundreds of years, does an excellent job of explaining even the largest large scale motions throughout the solar system.
Yeah. If I can add to that, what is fascinating to me is that we actually know orbits so well that we can navigate in deep space. So here at JPL, I'm sitting in I'm part of mission design and navigation section, and it really is I'm sitting among these navigators that are guiding the spacecraft from Earth onwards to different planets. And it is incredible what goes into planning and how precisely everything is executed. So you have to know the orbits of planets extremely well because you are moving so fast. I mean, we're talking about tens of kilometers a second. There is no room for error. You're going from one moving platform to another, and there is absolutely, you need to know everything. So it's very few people know that we know orbits, for example, of Venus, Mars, Mercury exceptionally well. We know where they are within a kilometer from Earth, with maybe even a few hundred meters. We know extremely where Jupiter is. So Jupiter is this really 5.2 AU, 5 times more distant from the sun than Earth is. And we know where Jupiter is within a few kilometers. We know where Saturn is within a few kilometers. So it is incredible what we have achieved and how we can do this deep space navigation.
And so a few minutes ago, we did establish, that there are no planets in our solar system that are moving backwards. And I want to hit on this fact once more. Are there asteroids or comets which actually do move backwards or in the opposite direction from everything else? Marina?
Yeah, so yeah, we mentioned already that there are comets that do go in retrograde direction from everything else, and we think that they came to be in these orbits because, as I said, there was some kind of gravitational interaction that ended up putting them, kind of flipping them backwards. And one thing that also is interesting to mention is that maybe, so in planets in our solar system don't go in retrograde direction, but some exoplanets around other solar systems, they do go in a retrograde direction. And that was kind of one of the kind of fascinating things, is like that, how do they get that way? Because you don't know whether, when the planetary system is forming,
Hmm.
how, and everything is spinning one way, how you still end up with a whole planet going the opposite direction. And so people have very interesting theories of how that flipping happens. But yeah, we do have retrograde exoplanets, not in our solar system, but this is, around other stars. And this is a curious thing.
And to follow that up, Henry, is there do you know of a retrograde orbiting exoplanet?
Yeah, I think one of the well-known ones is it's called WASP 17b. WASP is the name of the telescope
Name.
that discovered this. It was a wide-angle survey, and this is one of these um, telescopes, which is its job is to look for exoplanets out there by looking at I believe at the drop in the light that's from the star as the planet moves in front of it, and B means it's the second body in there, so that's the planet itself is going around the 17th star, so WASP 17b. And with this particular planet, we can measure the rotation direction of the star itself. We can observe that, so we can tell that the star is moving this way, and the planet is actually moving the other way around it. And as Marina was saying, it's hard to understand how it's going to be put that way, because you can't really, if you have one large cloud of gas, which is how we believe that most stars and planets form. You have a big cloud of gas. It's kind of like the tea leaves in your coffee cup or your teacup, that they're all spinning the same direction. And so we would think that with us forming a planet, it's going to form the same direction. Somehow, something's happened to this one, and it's going in the other direction from the star itself. And so this is a system which has been studied with Hubble. It's been studied with the JWST, and I'm sure we're going to find other ones which are similar to this, and eventually put that picture together to what's causing its unique motion.
Do either of you know, is that the only planet in that system that is orbiting backwards, or is the whole system going against its star's spin?
Yeah,
I don't
I'm
know
not
how many
sure.
planets.
Yeah, I'm not, but for that particular system. Yeah, I'm not completely sure. I can only tell you that kind of what are some theories of how this came to be. It all has to do with the planetary systems. Really, kind of, stars are not little islands, and planetary systems don't form in isolation. Usually, you have a cluster of stars. If you remember, Hubble has that kind of some famous pictures of a stellar nurseries in Orion, when these little kind of planetary systems are emerging from a ginormous like cloud of gas and dust. And so anyway, so it tends to be, they're so closely packed together, they tend to steal material from each other. And then that's how you end up with that. Most of the system is spinning one way, but you do have a part, sometimes even part of a disk. So it's not even planet formed yet, but it's a disk, part of the disk that is spinning the opposite direction. And so some interaction has to happen. Usually it is with neighboring star, or sometimes it needs to happen that this continues spinning one way, but the central star flips, ends up changing its spin state. Again, mechanisms can be pretty exotic. It can be even kind of this weird magnetic field of the star tilting the disk or something like that. So there's some pretty interesting physical processes need to occur in order for either star or disk to flip.
That is so cool. Thank you both for that explanation. And now, before we check in with some more questions on social media, I do want to share with everybody watching that you can actually see some of the planets and moons that we've touched on in today's show in the sky this month. Saturn, Jupiter, and Venus are all visible. Now, if you want to know when and where to look up, you can visit go.nasa.gov/what's up. Okay, let's hop back into some more of those Ask NASA questions. So we have a viewer on YouTube who asks, do dwarf planets also go through retrograde? Henry.
Yeah, so dwarf planets are going to be exactly the same in their motions um, as other things in the solar system. And so, in fact, the dwarf planets are further out than Jupiter and Mars and Jupiter and so forth. So, look at
Yeah.
Pluto, look at Eris, and so forth. And so, just like them, they're moving forward. They're moving in this counterclockwise direction, as you've seen from the top. But our orbit is going to overtake them because they're moving super slowly out there. So they take much longer to pass through the sky. So you don't see them moving so quickly in the sky. And so, dwarf planets are harder to observe. You have to use a telescope to observe them. You can't see them with your naked eye. So it's not quite like, with Jupiter, you can see the motion and you can actually see this loop. If you plot out Jupiter's position relative to the stars night after night, you can actually see that yourself.
With a naked
To
eye?
watch
Okay.
anything further out, like the like the dwarf planets, you really need a telescope so you can see them. But then you could plot out their motion and it makes a little loop in the sky as it goes backwards and then forwards again.
Oh,
And
well, you
Henry,
reminded me of something. You reminded me of something. You reminded me of actual retrograde, my favorite true retrograde dwarf planet, and that is Triton. So Triton is moon of Neptune, but once upon a time, it was probably just a irregular dwarf planet like Pluto that was orbiting the sun. But somehow in the early history of the solar system, it ended up being captured by Neptune. And you can see it orbiting Neptune in this weird, it is something size of Pluto. It's a huge. And it is orbiting in a different direction. So it definitely did not form with the planet itself. And one thing that we think is that that this capture of Triton ended up really wrecking the inner moons, the original population of moons that Neptune had. So so you see here that Neptune has 7 inner moons. We don't think this is the original population. They probably formed after the capture of Triton from the rings, because all these inner moons ended up colliding and just making like a basically big debris ring around Neptune, and the moons again coalesced, and they're now orbiting in the same way as the planet. But you see Triton looming in this retrograde orbit
yeah.
behind them. Yeah.
Cool. Well, thank you both for that. Our next question is Elisa Slay on Facebook, who asks, do other planets have north and south poles like Earth? And otherwise, how do we know with 100% certainty that the planets are tilted? Henry?
So we know the planets are tilted because we can take pictures of them. It's pretty simple. So you can go out there and you can actually see, with a small telescope, you can observe Jupiter, and you can see, Jupiter has belts of gas going on it, and they look like lines. And even a small telescope, a couple of inches across, you can see these. There we go. And so you can see those easily, and you can see you can see the motion of them, and you can see the orientation of them, and you can definitely distinguish whether they're this way or whether they're this way, and you can see where the planet is tilted. Now it's maybe easiest with Jupiter because it appears really big and really bright, but you can see it with you can see that in the other planets as well. Certainly, you can see that on Saturn pretty easily because the alignment of the plane of the rotation of Saturn is where the rings are. And so you look at the where the rings are pointed, and that's where how the planet is rotating. And so, the rings are like here, and then the North Pole kind of goes out like that. Um, the North Pole or the South Pole on any planet is going to point at a place in the sky, but that's not going to be the North Star. It's not going to be our North Star. It's going to be that planet's North Star, which is going to be different than Polaris, which is the Earth's North Star. And so if you go to one of those planets, the planet is rotating. It's got a North Pole. It's got a star probably somewhere around where that North
Straight up.
polar rotation axis is, but it's going to be a different star than what we recognize here on Earth.
Wow. And so my next question for both of you, well, it's for both of you. And Delinda on Facebook wants to know what both got you interested in the sky and the solar system. Marina, why don't you kick us off?
Well, I was kind of amateur astronomer since early age. And well, I was fascinated by the night sky, and I taught myself constellation very early on, and I had a little telescope, and I joined other amateur astronomers. I started observing meteors, and I studied physics, and so little by little, but it really was something that started in childhood and just propagated forwards. So I'm also, I have to admit, I am a sci-fi nut, so I do read a lot of sci-fi, and that probably also inspired me to work for NASA. So,
Henry, what about you?
So unlike Marina, I was not into astronomy when I was a kid. I was into dinosaurs, and I thought I would be a paleontologist. So then I went to college, and I didn't study anything about astronomy. But I spent a summer doing some astronomy research at an observatory, and I thought, like, wow, this is so cool. And at the time, there was a group of people who were looking at building a spacecraft to go out to Pluto, and I'm like, man, that is so awesome. So I kind of got attracted by that area and got attracted by studying about astronomy. And then I ended up going to graduate school and getting a PhD in astronomy because of this experience. And the more I get to do this, the more I appreciate that we are so lucky that we get to explore the solar system around us and figure out what makes it work.
Yeah, and it's only getting better. I mean, it's like every month, every day, every year, we learn something else. And so I love to see too that, there are many different pathways into careers like this, into being at NASA. So thank you both for sharing that. Now we have our next question that is from Z Art Gallery on Facebook, who asks, why do the planets rotate in different directions? Marina, do you want to take this one?
So we already established, most of the planets are rotating in exactly the same way as they are revolving around the sun. This just has to do with the initial conditions of how the solar system formed. We have two of them that are different. That is Uranus, that is tilted on the side 98 degrees, so it's kind of rolling. And then there is Venus, that is really spinning upside down. And there are just physical processes that can flip the planet from being upright to being sideways. We already mentioned potentially they got hit, they got just impacted. Mm-hmm. By a protoplanet during early days of the solar system. There are also some other explanations of that has to do, in the case of Venus, it has to do with the sun also influence on the very dense atmosphere that Venus has, and this friction that happens between atmosphere and mantle and the core that ends up kind of dissipating energy and slowing the planet down. I actually read one more theory on Venus, that it was basically, it was just slowing down because of the sun influence on Venus, that it was slowing down more and more, and then until it was kind of pretty much tidally locked, and then it started spinning the other way. So it never really went from here to here, it just kind of was spinning, started slower and slower, and then started going the other way. They're various theories. These are various theories that, you can cook in your computer.
Yeah, thank you. Thank you for that. And so earlier, Henry, you were talking about being able to see some planets in retrograde and others might be too far away. Can you see any planet that might look like it's in retrograde from Earth with the naked eye?
Yeah, so you can observe, people have been looking at the planets for thousands of years. People have, it's easy to see Mercury and Venus and Mars and Jupiter and Saturn. Those five you can see easily with your naked eye, like people have been doing for thousands of years. And the inner planets, those ones like Mercury and Venus, those are the ones which are overtaking us, as Marina was mentioning. And so they spend part of their time moving in from our perspective, moving forwards or in prograde, and part of their time moving retrograde or backwards in the sky. It's a little bit different pattern for the ones which are outside of us, Mars and Venus. I'm sorry, Mars and Jupiter and Saturn. Those are outside of us, and so we're moving faster than them because it's the closer you are to the sun, the faster you go because the sun's pulling you around
It's like the
faster.
racetrack.
So these outer planets would like the racetrack, exactly. So
Yeah.
we're kind of on the fast lane on this racetrack since we're closer to the sun. We're overtaking Mars and Venus, and it's just like looking out the window of your car as you're overtaking someone on the highway. That you look, you've got this slow truck on the slow lane that you're passing beyond. You look out your window and they're going behind you. It looks like they're going backwards. There, you're actually still moving forward, but from your perspective, it looks like they're moving backwards. And that's what we mean by retrograde for the outer planets.
Well, thank you both. We have time for one more question. And so I actually have one for both of you. Marina, we can start with you, and then Henry would love to hear your thoughts. But do you have any advice for our viewers that are, potentially considering a career or a path in astronomy?
Well, I can tell you that, here at JPL, I've been working with some people that have been in the field, the STEM field, for 40, even 50 years. And I still, these are both scientists and engineers, and I can still see that they have that same spark in them that they probably had early in their careers. So my advice is that study that math very hard, because
Mm.
knowing math can lead to a very happy and long career.
Henry?
So I would say advice for anybody, find something that you really love to do because that's what you're going to be the best at, and that might be in astronomy, it might be in math, in physics, in design or engineering, or writing, or in building things or art or whatever it is. And people at NASA do all these things. NASA is not just astronomy, but NASA involves all of these wide variety of other things. So find the thing that you love, keep doing that, be great at it, and there really are possibilities at NASA for everyone.
Yeah, and who knows, 40, 50 years down the line, you've still got that same spark. And so thank you both for that fantastic advice. And two, just for all of your help breaking down planets and their orbits and what retrograde actually means today. Thank you.
It was a pleasure to be your guest.
Thanks for having
And
me.
thank you to everyone who joined us online as well. It was so fun answering you so many questions about your favorite planets and again, what being in retrograde actually means. Now, we hope you'll keep up with NASA's efforts studying our solar system and beyond, and you can do so by following NASA Solar System on Facebook, X, and Instagram. Now, if you're looking to deepen your personal connection to the amazing places that NASA studies, you can visit go.nasa.gov/what's up. There is always something to observe in the night sky, and with NASA's monthly tips, you can know when and where exactly to look up. Again, thank you all for joining us and hope to see you next time.